Hello, grade 12. I'm going to do another example on chem. This example comes from a worksheet. This worksheet says now, draw a chem displacement graph and a profile to the following specification. You have the direction of rotation, which is anti-clockwise. The follower is the wedge-shaped follower. Camshaft diameter is 20 millimeters. The minimum cam radius is 20 millimeters. I will start with the camshaft diameter of 20 millimeters. Before I could draw any circle, first of all, the first thing that I want to do is to have my center line. There, I will have my center line. Then the camshaft diameter, they told us it is 20 millimeters, which means the radius will be 10 millimeters. Make sure that your hand is steady and you have a good quality compass. There we are. And then I immediately hatch it with my 45 degrees set square, because I know that the cam has been cut. The cam has been cut so that you are able to see the profile. Here is our cam, and then you get a mark for this minimum thing that we have done here. And then you have the minimum cam radius of 20 millimeters, the minimum cam radius, which is the lowest point that the cam will move, is the radius is 20 millimeters. 20 millimeter radius. There is my 20 millimeter radius. Minimum cam radius. Minimum cam radius is done, and then the follower is a wedge-shaped follower. It has not the dimensions of the thickness of the follower and so on and so forth. The height was not given to us. So a wedge-shaped follower is a follower that looks like this. I will take any dimension because I have not been restricted. I have not been given the diameter of the follower, but you can measure any. It can be of any size. Here is mine. It's a wedge-shaped follower. And then the direction. They say the direction of rotation. The direction of rotation is anti-clockwise. We all know the movement of anti-clockwise. We show the direction. We are collecting marks by doing that. The direction is anti-clockwise. Here is an anti-clockwise, which indicated by an arrow. It's moving anti-clockwise. Now, they say use the horizontal scale of 10 millimeters equals to 30 degrees. Before we come to that, we'll go to the follower. How does the follower performs? One, it says it rises by 20 millimeters, and then over the first 90 degrees due to uniform velocity. It relaxes, it dwells, it rests for 30 degrees. There's no movement. It rises again by 30. Already now it has risen by 50. 20 plus 30 is 50. It rises 30 millimeters to a maximum displacement over the next 90 degrees. And then it falls to a minimum displacement. It falls back now, which means the rise is 50. Because after it has risen 50 millimeters, it's going to fall back to its original position. Now, this is the minimum distance. That is the cam at its lowest point. It is there. Now, at its highest point, where will I determine? Find a space just next to it and find the highest point, the highest, which this size will be a maximum of 50. We said it is 50. Remember, the rise is 20 plus 30, so which is 50. Here is my rise. It is 20 plus 30, which is 50. That will be the maximum height of my cam. So my cam follower will rise up until here. It will rise up until here. So I might as well make a radius of the maximum height of the follower. That is the maximum height of the follower. That is the maximum height of the follower. And then this one, it will be the minimum. That is 50 millimeters from here to there. It is 50 millimeters. Now we will come now to the movement. We'll come now to the rotation in degrees. Now they say use a horizontal scale of 10 millimeters equals to 30 degrees. 10 millimeters equals to 30 degrees. So we know that our rotation will be 360. So 10 degrees is 10 millimeters is equal to 30 degrees. And now let's do that. 10 millimeter, which means our displacement, our rotation, movement of rotation is 10 millimeters. These 10 millimeters that I'll be drawing, I'll be marking off here. It will represent 30 degrees. That is 30 up to 360, 30, 60, 90, 120, 120, moving, 120, 150, 180, 210, 240, 270, 300, 330, and 360. Let's verify that. This is 0, 30, 60. This is 90 degrees, 90, 120, 150, 180, 180, 210, 240, 270, 300, 330, 360 will be there. And then we make our divisions there quickly. Hey. Right. We know here we have move this a little bit. just write everything here. This is our rotation. Remember, this thing is rotating 360 degrees. It's for one revolution. So here we have our rotation. You state that this is our rotation. Our rotation, which simply means 10 millimeters. Where is the question paper? Horizontal 10 millimeters equals to 30 degrees. Scale is our scale here. Our scale will be 10 millimeters equals to 30 degrees. We are accumulating marks by doing that. And then also on the other side, the displacement. Obviously the displacement will be 1 millimeter equals to 1 millimeter. From our displacement, one millimeter equals to 1 millimeter. 1 millimeter equals to 1 millimeter. Now let's move. Let's go on. The follower movement. It rises 20 millimeter over the first 90 degrees. 30, 60, 90. It rises 20 millimeter. 20 millimeter is from here to there. That is 20 millimeter. It rises 20 millimeter during the first 90 degrees. There is 20 millimeter there. From here to there is 20 millimeter in the first 90 degrees. And then it dwells for 30 degrees. To dwell, it remains at the rest. It doesn't move. 30 degrees. 90, here is 30 degrees, which is up to 120. It dwells. It dwells. Okay. There is no movement of the follower. Our follower does not move, but with uniform velocity, which simply means this is how we represent it, that motion that it has moved from 0 to 90 with uniform velocity. Yeah, this is the first 90, and then the second was 30 degrees where it dwelled. It remained at the rest. And then there is another rise. It rises 30 millimeters to a maximum displacement over the next 90 degrees. Over the next 90 degrees due to simple harmonic motion. It rises 30 millimeters. 30 millimeters, which means that is 30 millimeters. Remember, we said 20 plus 30. But what is the duration? Over the next 90 degrees. Over the next 90 degrees. We are going to count 90 degrees. 30, 60, 90 degrees. 90 degrees it will be there with simple harmonic motion. So now we are going to represent that simple harmonic motion now on our graph, on our displacement graph. Now there, from here to there, it represents simple harmonic. So you will find space anywhere. You may find space if there's enough space that side. You can do that, but I'm going to use this side. This is where I have space for this 30 degrees. How do I construct that? My simple harmonic movement. I will first have now, where is my ruler? There it is. Remember, it is 30. For 30, half the radius of 30, half of 30 is 15. There is my 15. There is 15. 15. from the corner, half of that 15 will be here. Now we'll draw an arc. Draw an arc. There is an arc. So here we look at it, and then we will divide our arc maybe into 3 equals. We are going to decrease 30, 60, 90 degrees. Let's check. Let us divide our arc here. 1, 2, 3, 4. After I've done that, I will transfer these horizontally. There we are here. 1. The first one automatically it was here. 1 from here. With that, you move up. That one, and then you move to the third one. There we go, but it is on this space here, and then the center, that will be my center, and then I move to the next one. That one, take me up to there. Move to the last one. That one takes me up to there. There we are. Now I've made it 3 equal divisions here. Take a look at this. From this corner to the center. From this corner to the center, it was 1, 2, 3. 1. Okay, oh, I did not make that line, but it's there on the other side. Right. It is 1, 2, 3. 1, 2, 3. 1, 2, 3. Now I've made 3 equal divisions. Now, you look at this. You find the midpoint, so that half of it will go with that half. With that half, the other half will go with the bottom half. So I must start counting from this point to that point. I move 30 degrees, 30 degrees, plus 15 degrees, which is somewhere here, plus 15 degrees, 15 degrees. Come in, 15 degrees. So that will be that 15 degrees that I'm talking about. That will be that 15 degrees that I'm talking about here, which will be my center. Then I'm almost done with it now. With simple harmonic, I'm almost done. I'm almost there. Now, from here, it will be from this point to that point. 1. Oh, remember I must divide it into 3 equal parts. So it is 1, 2. It's not 3. It's not 3. They must be 3 before I reach the center. Even here, I would want to find the midpoint here. The midpoint, my midpoint, it's somewhere here. Even that's, yeah, my midpoint is somewhere here. There is my midpoint. It's 5 millimeters. It's 5 millimeters. My midpoint is 5 millimeters. So we will have 1, 2, 3. 1, 2, 3. So then you join. It will be a curve like that here. It must be like that. That will represent my simple harmonic movement. Wow. Yeah, I think we are done with it. That is simple harmonic movement. And then it says now it rises to a maximum displacement over the next 90 due to simple harmonic motion, and then it falls. Now as it falls to a minimum displacement over the last 150 due to uniform acceleration and retardation to the next during over the last 150 degrees. Let's count: 30, 60, 90, 120, 150. On this one now it falls to its minimum position. From that is the minimum position where it started. It falls to this minimum position. It ends there. So let's check. The half of, because it falls by 50, half of 50 is 25. Half of 50 is 25. Let's check on my 25 here. That is 25. Half of 50, there is 50. Half of it is 25. There is my 25. Look where I put my 25. I make sure over this last 150 degrees, which is 30, 60, 90, 120, 150, half of that is here. It's 1, 2, 3. Oh, am I right? No, it's not there. It's not there. It is somewhere here. It is somewhere here. Half of it is somewhere here. So I will also make those divisions. Half of that, it's 5 millimeters. Here, right here, it's 5 millimeters. There is my 5 millimeters. I would like to just to draw my division of 5 millimeters here for a simple for a acceleration and a reduction. So this, now you want to divide this part into 3. I will divide this into 3 equal parts. Even that on the other side, I'll divide it into 3 equal parts. So if I divide that into 3 equal parts, it will mean, that will mean I must have a calculator with me here. Where is my calculator? I must have a calculator with me so that I know the actual number of degrees that I need to have. The actual number of degrees that I need to have. Let me start first by doing this. Where is my calculator? There's my calculator. Aha! Come on, why is it so slow? No, it's not my calculator. This one. I want my calculator. Yeah, there is my calculator. There's my calculator. I will start dividing this one, which is 50. Let's call it 50 divided by 6. I say it's 8.33. Okay, which will mean something like this here. That will be 8.33. I'm dividing this into 3 equal parts. 2, 3, and then I'm dividing that. It will be 1, 2, 3. 1, 2, 3. I've divided into 3 equal parts, and then from it is how many degrees from here, this distance, from this distance I will divide it into 3. This distance, I no longer now consider those 30, 60 degrees and so on that are already there. I want to divide this into 3 equal parts, this distance here, so that it can be even. So that will mean 19 divided by 3. Okay, where is it? divided by 3. That will mean almost 6 millimeters apart. These are the lines that I'm putting for myself. Here 1, 2, okay, 19 divided by 3, okay, yeah, that's 6, 12, no, I was wrong, it's not 19, it did not count well, it's not 19, it's about 24 millimeters, 24. Okay, 24 divided by 3 gives me 8. Sengimakhe kakhulu lapha ngiyenza bo 8 bamla. Gives me 8. Divide that. There is 8. 1, 2. Can't be, man. It can't be. Wenzakala. That is 9. It's 8. It's supposed to be 8. Wow. Yeah. 1, 2, 3. 1, 2. Right. 3. Okay, it might have taken me a little bit longer. This one, it is somewhere here. Just for you, so that you are able to know what I'm talking about. It is 1, 2. The third one that I've already done for myself is this one, this line. And it's constructele yona. And that one. And that one. 1, yeah, it is 1, 2, 3. 1, 2, 3. Now I'm line number 3 now. So, which means when we start here, we will start here. Draw a line. Here is my center. If you are still with me here, here is my center of the remaining 150 degrees. There is my center. I've divided into 6 equal parts, and then even this side 6 equal parts, 1 up to 6. So those parts that I've divided, I've marked them with a 0 here, just to distinguish from the original lines that I'm having. These ones, it's just to distinguish for you, so that you are able to understand what I'm trying to do. So now I will start moving here into this up to the center. I'll move 1, 2, 3. 3. And then from this end, that center, it must be in line with the last part here. It must be in line with the last part here. Right, it must be in line with the last part. Then I will start now numbering here. 1, 2. The third one will be there at the bottom. Now, as it acceleration and retardation, as it accelerates, we start. The first line is this one. Where is that 0? This thing, this part here, it is here. 1. The second one, 2. The third one is there. Then I will make a curve. Right, and then again the first one, the first in line with this 0 is here, 1. The second one is here. The third one is there. Then I join. Aha. Here is my uniform. That is my retardation, acceleration, and retardation. Now I've done my displacement. Now it will be much easier. Now I'm going back now to do the what do you call now, to get the profile, the cam profile. We will project from 30, 60, 90, 120, 120, 150, 180, all right round. We'll make those projections. It's something that you already know. You have done it in grade 11. So maybe you might not be able to see all of that as I'm projecting, but I'll try and show you the maximum that I can. With my 0, 0 is already there. There is 0. My 30, that is 30, 60, 90, and 120 are in that third line. Oh, yeah, but I forgot to divide. Remember, we always divide this. Oh, let's divide into 12. Right, since it is moving anti-clockwise, this thing is standing still. It will just move up and down. There is 0. 0 starts here. 0 and 360 are here. So the cam is moving. This is the cam moving. So from 0 it will be 1, 2, up to 30. There will be 30 degrees on this side. 90, 180, 270, 360. That's the secret. You also get a mark for that. The 30, because it's the cam that is moving towards the follower. It is the cam that is moving towards the follower. So your 30 is on the other side. If it was clockwise, it will be 0, 1, 2. There will be 30 coming from that other end. Now, I've already started with my 30. Oh, there is 30. 30 is here. And then is 60. We all know that, guys. 60 is there. 90 is there. 90 is there. It dwelt, no 120. As I move 120. And then we go to 90, 120. Look at what I'm doing now. If I'm looking for sometimes to save time, if I taking that center here from 90 degrees, I extend it. I might as well take it. It's 90, 120, 150. 150 is there. There is 150. 150. 150, 180, 180 is there. 180, 180, 210. 210 is there. So 210 is there. And then The next 210 is there. Uh, 210, which is 250, 210, 250, 28, 210, 240, 270, 270 is there. Wait a minute. Where was this one? This one is 180, 210, 180, 210 is maximum. And then we have 240, and then we have 270. Yeah. 270. My 270 is here. This is my 270. 270 is here. After, oh no, ngibale wrong. Hey, when's the part? 270. 270 is here. Sorry guys, 270 is here. I'm just taking some shortcuts. 270 is here. 270, 300. Yeah, come in. 300. 300 will be here. Oh, transparent. 300 will be here. Yes, please. 2 minutes. 300 is here. And then 330. Hey guys, I will have to take a pause here. 330 is here. 330. 330 is here. Yeah, 330 is here. And then 360 is there. So we will join all those points. But for now, I will take a pause and I will come back. Yeah, and now then. Since we have marked all our points there, we are going to join them. We are going to join them to create the profile. We are going to join them to create the profile. So, from here, there was 30, 60 as it goes. You just start it nicely, very, very faintly. I prefer doing it freehand. Can do it freehand. You can use your, what do they call that stuff that they use? French curves. You can use your French curve. You can do it freehand. It's okay, but there's no penalty for not doing that freehand, for not using a French curve. Do it like that nicely, and then once you are sure that then you can start solidifying it, but make sure that you have a steady hand, baba. Azoba matatazela. Sesemncane for ukushake isandla mfana yithi. Practice your freehand sketches on your pads. You have done that, your freehand drawing, so you must be a master of that one. Then you will have it like that. This will be your profile. This is how the design of your cam will look like. I hope you have enjoyed it, or you have, at least if you did not, you have learned something. Thank you. See you in the next video. Grade 12s.